Welcome to Statistic Learning Session. Today we'll be talking about goodness of fit test. Last slide we had a x as a random variable. We had a distribution of p, and we want to understand whether p was equal to p naught. To do that, we need to understand the likelihood of whether p is equal to p naught. That's what we understand. For that, we need to understand the distribution of p, or PMF of P. For that, we're going to use the likelihood or likelihood test to understand to compute the PMF. What I mean is, to test whether P is equal to P naught, we can use likelihood test, and that likelihood test is called multinomial likelihood. Now, if you look at this slide, what we have here is the x through xn, and is distribution of P. These probabilities of each possible outcome is called modality. So x, if you take x of the multinomial distribution, x can have only a certain number of output. In binomial, it can have two output. In multinomial, it can have key outputs. So these key are called modalities. Now, if you go back to our previous example of CEOs, there were 250 CEOs, isn't it? 256 CEOs, isn't it? And each CEO can have 1 out of 12 possible zodiac signs. So those 12 are modalities. And yes, we are saying that we are taking a look at CEOs, and we are going to each of one of those 256 and saying that this is a sign of this is a sign of that. Can you do other way? Can you group by the sign itself? Can we take 12 signs and say that for zodiac, for a Leo we have this many CEOs, for Libra we have this many CEOs? Can we do that? Think about it. Yes, we can. We can do that. We can go and count the number of zodiac sign for count number of CEOs for each zodiac sign. This is called sufficient statistics because that's all we need to know. Now we have all these data points of CEOs, and let's say I want to conduct a multinomial experiment. How will you do that? Think about it. When you conduct a multinomial experiment, let's say we have all these CEOs, and say these are just simply a balls in a bin, and we have all the CEOs of last 20 years of Fortune 500, and each ball can be have a key possible outcome or 1 to 12. And what we'll do is that we'll put our hand inside the bin and take one ball out, and either it's a Scorpio or it's one of those 12 star sign, and we record on a piece of paper, and we take another ball out, and this comes to be another Scorpio, and we just add to that, and we take another ball out, and this happens to be a Libra, and we put a new entry. So in this way we go through all those 500 CEOs or 500 bins, 500 balls, and we record them, and we'll have a K colors or 12 different 12 different colors which are representative of the star sign. We'll have 12 different colors, and each 12 different colors will have a counting or number of balls of each of those color. So that's going to be a is equivalent experiment of the number of CUs. And then here the k colors or 12 colors will be analogous to the number of star sign. And when k is equal to 2, that happens to be a binomial experiment. Now, moving on to understand what are the parameters of multinomial experiment. Just think about it for a second. What are the parameters of a multinomial experiment? The parameters of multinomial experiment is the proportion of each color of the ball. Let's say I have for red ball, it is 10 out of 500. So those are parameters for each of the ball. And the same thing can be for blue ball. How many blue balls do you have out of 500? Those are going to be the parameters of the experiment. And let's say for our purpose, we're going to see each parameter will be defined P1, P2, P3 up to Pk. That's how it works in a multinomial distribution. When we say